Hi everybody. I'm just going to run through a few examples on how to use the formula n equals c times v in a stoichiometry question. So what might be best is you pause the video, read the question, perhaps set it up, so on and so forth, and then when you get stuck, then play the video and wait till I catch up to you, and then just keep going that way. I'm just going to keep going though with this. All right, so first thing we have to do in any Stoich problem is we have to write out the chemical reaction. So I'm reading this quickly, and I'm just basically trying to find what's reacting with what. So I know magnesium is going to react with hydrochloric acid. It's going to produce hydrogen gas and magnesium chloride, okay? It's a single displacement reaction. So we got magnesium, which we know is a solid. It's going to react with hydrochloric acid, which would be a solution. It's aqueous, and it's going to make hydrogen gas, which is H2. It's one of the bloody seven, and magnesium chloride. Now, symbol, valence, crisscross is going to give me that. And because I'm asking for the concentration, it is a solution. Now, if this was the exam, you'd have your solubility rules, and you would look to see if that is soluble. The reason why we're going to see if this is soluble is because we have water on the reactant side, okay? This is a solid, but we have hydrogen chloride gas that is dissolved in the water. Okay, so that's first thing. Second thing we have to do is now we have to balance it. So this is a pretty easy one to balance. I'm just going to put a 2 in front of the hydrochloric acid. All right, so that's step 1 and step 2. Now we're going to set up our columns. And I'm going to put down all of my givens. So I know we have 5.8 grams of that. Mass and molar mass go hand in hand. I'm not going to quite do that yet. All right, 150 milliliters of hydrochloric acid. That is a volume. And I automatically change that to liters right away, so I don't forget later on. 0.5 moles per liter, that's concentration. I want to know the mass of hydrogen gas. I need to know the molar mass. And I also want to know the concentration of that. So that's pretty much finishing up all the givens. Now I'm going to go and I'm going to calculate the molar masses. So magnesium is easy. That's just looking it up on a periodic table. And I get 24.3 grams per mole. And for hydrogen, that's going to be 2.0 grams per mole. Now, this isn't the easiest of stoichiometry questions. If you've been doing your stoichiometry all the way through, then the easy ones really you're not going to have any issue with. This one is a limiting reactant question. Because I've given you information on both reactants, we need to figure out which one is going to run out first. Okay? So I have to convert mass to moles, and I'm going to have to convert concentration to moles. So for the magnesium column, number of moles is mass divided by molar mass. So that's going to be 5.8 divided by 24.3. And when I do that, I get 0.239 moles. Okay? Convert this, n equals c times v. It's going to be 0.5 divided by 0.15. I'm going to get 0.075 moles. Now, I need to figure out which one runs out first. I can tell you right away, I know this one's going to run out. It's consumed at a faster rate, 2 versus 1, and I have less of it. But again, for those of you that always want to make sure with math, instead of just assuming that, and divide that by 2. And this one is just going to be that number divided by 1. So that's going to be the same number. And I can tell this one's going to be smaller without actually even doing the calculation. Okay? All right. Now, this is really the new part, is you're finding number of moles using a new formula. This is what I'm going to use in my mole-to-mole calculations. So we have line equals line. The original ratio is 2 to 1. Instead of 2 moles, I have 0.075. And I need to find N. And I get 0.0375 moles. Wanted mass. Mass equals number of moles times molar mass. 0.0375 times 2. And 0.075 grams. So not a lot of it. Okay? Again, need to find concentration. Now this is a little bit different. If you get stuck on a question like this, remember, I'm going to give you lots of part marks. And I'll go through when we're done with this one to show you kind of how I would mark this. I do know I need to do a multiple ratio. So I'm not going to stop. I'm still going to do that. The original ratio is 2 to 1. 0.075. So it's going to be the same number I just calculated. This one right here. 0.0375 moles. Now, concentration is number of moles divided by volume. Now, the number of moles I just calculated. That's not a big deal. What the heck are we going to do for volume? Nowhere in the question do I mention what the volume is of this. Now, this is the understanding component of this. What you would have had is you would have had a beaker, and in that beaker, you would have had 150 milliliters of hydrochloric acid. That basically means you have 150 milliliters of water, and in that 150 milliliters of water, you have hydrogen chloride that you would dissolve. Now, of course, the hydrochloric acid is already prepared for you, but that's kind of what it means. So that means you take a hunk of magnesium and you would drop it in the beaker. Now, how much water did you have? 150 milliliters. The magnesium would bubble away. Hydrogen gas would be produced. In the end, right, you're going to have a little bit of magnesium left over. We know that because this is the excess reactant. No hydrochloric acid would be left. But guess what? You're still going to have the water. So we know that the volume on this side is 150 milliliters. Okay? So the total volume on this side is 150. The total volume on this side has to be 150 as well. It's irrelevant for this because this is a gas and would bubble away. All right? So that makes this easier. Again, make sure this is in liters. So that is my volume I'm going to use. And I end up with 0.25 moles per liter. All right. So again, this, I know this, I started at 5.8 grams and I ended up with leftover. There would be a little bit of magnesium left at the bottom. I started at 0.5 molar or moles per liter. I'm going to end up at 0. Now you could also say you started at 0.075 moles and you're going to end up with nothing. This you started at 0 and you've made 0.075 grams. This you started at 0 and you made a concentration of 0.25 moles per liter. All right. So that's that example. That's kind of a medium example. This one is tough. This is one that I tend to like to do on the exam. So this one here, again, if you pause it and kind of read the question, set up the formulas, balance it and all that, go ahead. Okay, so we are reacting lead 2 nitrate with ferric chloride. It's a double displacement reaction. So lead 2 nitrate, lead's going to have a valence of +2. Nitrate is -1. When I crisscross, I'm going to get this. It's aqueous. I know that because it's a solution. It's going to react with ferric chloride. So iron has 2 valences, +2 and +3. Chloride is -1. Now ferric means I'm going to take the higher valence. So when I crisscross the 3 and the 1, I'm going to get that. Again, that's a solution. We are going to make a lead 2 chloride. So again, Pb +2. Chlorine is Cl -1. Crisscross gives me that. It's a precipitate. That means it's a solid. It would not be soluble. And we are also making ferric nitrate. So ferric, iron +3, nitrate NO3 minus 1. When we crisscross, we got to put the nitrate in brackets and have that. And again, that would be aqueous. We know that because we were asking for the concentration of that. You'd also look on your solubility rules, and nitrates are soluble, no exceptions. Now we got to balance this. Let's see, we got 3 chlorines here, 2 chlorines here, so that's a 3-2 combo. So if I make it a common number of 6, I'd have to multiply that by 2. I now have 6 chlorines. Multiply that by 3. I have 6 chlorines. I have 2 irons there. I now have 2 irons there. I have 3 lead, 6 nitrates, 6 nitrates. We're balanced. Okay, so we're done that. Next thing we have to do is we have to set up the columns. All right, lots of information we have to write down here. Okay, the concentration of lead-2 nitrate is 0.5 molar, which is moles per liter. We know it has a volume of 200 milliliters, and I'm going to convert that to liters. Let's see, ferric chloride has a volume of 150 milliliters. We're going to convert that to liters right away, and has a concentration of 0.5, again, moles per liter, or capital M, which is molar. I want to know the mass of my precipitate. Going to need molar mass eventually. And I want to know the concentration of my ferric nitrate. Okay. So the first thing I'm going to do is I'm going to find the molar mass of lead-2 chloride. So lead has a molar mass of 207.2 plus 35.5 times 2. And I am going to end up with 278.2 grams per mole. All right. Again, this is a limiting reactant question. Specific amounts of both reactants were given. So I need to find the number, which one's going to run out first. So I'm going to use N equals C times V on both of these columns. Whoops, N equals C times V. That's supposed to be an N. All right, 0.5 times 0.2, which is 0.1 moles. 0.5, 0.15, and I get 0.075 moles. Now, in this particular one, I don't feel comfortable just predicting which one is going to run out, so I'm going to very quickly figure this out in my little rough thought cloud. So it's 0.1 divided by 3, and I get 0.03 repeated, and I'm going to do 0.075 divided by 2. I get 0.038. This one is going to be smaller, so that one runs out. So this is going to be my limiting reactant. And remember, I'm going to circle that. And I tend to just scribble through this lightly so I know not to use any of that. Okay, now from here, once we do this, this column is fairly simple. Got to do a multimole ratio. The original ratio is 3 to 3. And instead of 3 moles, I have 0.1. So the number of moles is 0.1 moles. And I want to find mass equals number of moles times molar mass. 0.1 times 278.2. When I do that, I get 27.82 grams. So that's a fairly significant amount of precipitate. Okay, now I got to do a multimole over here. The original ratio is 3 to 2. Instead of 3, I have 0.1. So I need to find N. So I'm going to do 0.1 times 2 divided by 3 equals, and I'm going to get 0.06 repeated, so we'll go 6.7 moles. Same idea here. Great, I need concentration, N divided by V, but I need a volume. Now in this particular one, you have 2 solutions. You have one beaker, you're going to have 200 milliliters of water. In it, you're going to have the lead-2 nitrate. In another beaker, you're going to have 150 milliliters of water, and in it, you're going to have your ferric chloride dissolved, your ferric chloride dissolved in it. Now, when you mix these things together, you're going to take both separate beakers and pour them into a bigger beaker. When you do that, your volume is going to be the 200 milliliters plus the 150 milliliters. Okay? Now when I do that, I'm going to get 350 milliliters, which is 0.35 liters. So that's really your biggest trick here. So now 0.067 divided by 0.35. When I do that, I get 0.19 moles per liter. Okay? So part of this that we've just done, I know I started at 0 grams and I'm making 27.82 grams. I've started with 0 of this and I end up with 0.19 moles per liter. I started here with 0.5 moles per liter and I'm going to end up with nothing. That's what a limiting reactant is. So I've answered most of the questions. Now, I asked for the concentration of both reactants at the end of the reaction. So the lead 2 nitrate is going to have a concentration of 0. There's not going to be any of it dissolved in the water. But there is going to be some ferric chloride that's dissolved. So this is the hardest part. This is the most difficult part of any Stoich question that you're going to have. So I'm going to do a line. Remember, this is what I started with. I started with 0.5 mole per liter, and then I just converted it to moles. But this is my starting amount. So now what I'm going to do is I'm going to do a mole to mole over because I want to know how much I'm going to use up. So the original ratio is 3:2. Instead of 3, I have 0.1. And when I do this, I'm going to get 0.067 moles. Okay? Now, I want to figure out how many moles I have left over. So I'm going to take the number of moles that I started with, 0.075, and I'm going to subtract 0.067 from that. So when I do that, I get 0.008 moles are going to be left over. So concentration, this is easy, right? N over V, 0.008. Now, volume, you aren't going to use the 150 milliliters because you've mixed both of these solutions together. Remember, all of this is in one beaker. So I have to divide that by 0.35, which is the solutions all put together. And when I do that, I end up with a final concentration of 0.23 moles per liter. Now, that should be less than what I started with, and it is. So in this case, I started at 0.5, and I ended up with 0.023 moles per liter. I promised to tell you kind of how I mark this. So in this particular one, I don't give you any of the formulas. So I would give you a mark for each formula, and I'd give you a mark for balancing. So there's 5 marks right there. 6 for givens, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's 24 marks. If I had you do these things showing me the before and after, then I would just add to that. Okay? So that kind of shows you that there's lots of part marks in this. So you may not get perfect on a Stoich question, but even if you ran in difficulty and you couldn't do this part, you're really getting a lot of marks, right? You would have gotten 20 out of 24. And then even if you don't get this, you'd get this, you'd give me the formula, and you'd lose another 2 more marks. And now you're getting 18 out of 24, which isn't bad. It's 75%. And really, you didn't do anything in this column, and you didn't finish up this column. So 75% is not bad on one particular question. So good luck on your questions. Hopefully you just fly through them.